All right. Well, hello, everyone. I'm Penrin. I lead developer relations at Worldcoin, and I'm here to talk about global proof of personhood with World ID, the protocol developed by Worldcoin and Tools for Humanity, supporting the Worldcoin ecosystem. So in this workshop, I'll go over what World ID is, why Worldcoin created it, what you can do with World ID, and most important part, how to integrate World ID. All right. So World ID answers this question of like, how do you know who or what is a real and unique person? Worldcoin started out as a project that wanted to give everyone in the world a little bit of cryptocurrency to introduce them to this digital economy. But in order to do that effectively and fairly and not get a bunch of money taken by bots, you basically have to solve the Sybil resistance problem. So we did, right? That's why we built World ID, which also, fun fact, as of yesterday, is now publicly available. So for those of you who have hacked on World ID before and remember having to scan a QR code to get access to the dev portal, that's done. All of you can build on World ID now, which is great. Right? So we need World ID to be private, inclusive, and robust. Right? We want this proof of personhood system to not unnecessarily disclose any information about who you are, and keep that privacy and anonymity wherever possible. We want it to be inclusive, right? This needs to be something that as many people in the world can use, especially when our mission is introduce the entire world to this new digital economy. And we also need it to be robust, right? We need to make sure that every real person can only get one account, right? So as many real humans as possible, but each one only gets one. And we also don't want to know which real human you are, just that you are a real human who's unique. So when we look at ways that we can go about sort of building this system, right, we looked at like verifying emails or phones, which is nice and simple. It's super accessible. It's also not robust in any way, right? I myself have multiple emails and multiple phone numbers, and that just breaks one of the three core pillars of what World ID needs to be. We looked at doing KYC on official government IDs, but the problem with that is that less than half of the global population has a digitally verifiable government ID. It's just not inclusive enough for us. We looked at Web of Trust systems, but the issue with Web of Trust systems is that, you know, when you start with a core verified set, right, of 100 or 1,000, to scale that to all of humanity, you have to get a lot of hops of verification away. Where like person A verifies person B verifies person C. And eventually you're like 20 hops away from that initial verified set. And every single hop is less trust that you can have that web of trust actually is working effectively. So with that, we settled on biometrics, which initially sounds scary, and skepticism about it is a good thing, but we do manage to do it in a privacy-preserving way. When it comes to the biometrics that we use, we looked at fingerprints and face scans and palm scans, but the issue with those is that there simply isn't enough information to distinguish people on the scale of humanity. Touch ID and Face ID on your iPhone can distinguish about 1 in 30 million people, which works just fine when you're trying to prove that the person in front of the phone right now is the same person who was in front of the phone, you know, months ago when they set it up, right? The odds that like the person who steals my phone in the United States is one of 10 people in the country who would also be able to unlock my phone, I'm happy with those odds. But when we're trying to prove that you're different from everyone else who's in like the global population, 1 in 30 million doesn't cut it for us. We also looked at DNA. Problem is that it's highly invasive in every way. It's impossible to do that in a way that doesn't tell you a lot about that person. So that one got cast aside pretty quickly. And we settled on the iris, right? The iris has far more entropy than fingerprints, palm prints, face scans. It's well studied. And additionally, it's really, really hard to do it without someone consenting to it, right? If someone is trying to like scan your iris, you can close your eyes, right? And it's the kind of thing where at the level of detail that we use with the orb, it's not something that you can do passively. It requires your attention. So that like consent is sort of built into the system as well, which is important when dealing with biometrics. So then, now that we've settled on iris verification, how do we actually want to implement that? Phone sensors sound great. A bunch of people have them. Problem is that the quality isn't super great, and it's also not a trusted hardware solution. You can't be sure that someone isn't just piping in a bunch of fake data to the camera module, right? For off-the-shelf hardware, similar situation. It can be a more trusted environment, but it still is not fully trusted. And again, we ran into issues with the quality of the photos of the iris it was able to take. So we settled on building custom hardware, which, taking the leap from we want to give everyone in the world a little bit of cryptocurrency to we're a hardware company, it's a really big leap. And I always just think it's really funny how that's what ended up happening. But this is the custom hardware we built, the orb. We have 4 of them down at our booth as well. So what the orb does, the orb's been in development for quite a few years now. It started development right before the pandemic hit back in 2020. It's gone through a lot of evolutions in order to make it more secure, be able to scan people more quickly, things like that. There's an incredible amount of engineering that's gone into this device. So the orb makes sure that you're a real human, right? It can tell if you try to put a cat or a dog in front of the orb. It takes photos of your irises and on device without ever needing to store those photos anywhere. Calculates an iris code, a digital representation of the entropy of your iris. And then, once it's verified that that iris code is unique to all the other iris codes that have been signed up, your World ID is then verified. So your World ID is a self-custodial identity stored on your mobile phone. And when we verify that, we actually take the public key of that identity, put it into a Merkle tree on chain so that you can then generate zero-knowledge proofs in the World app, attesting that you are one of the identities in that set without revealing which one, so that you can maintain that privacy and anonymity that we want to help you maintain, while simultaneously proving that you are a unique human and being able to prove that you're only taking a specific action once. So when it comes to Sybil resistance and knowing that someone isn't a bot, it's an incredibly powerful solution to do that when you don't even have to tell Worldcoin your name, right? So yeah, World ID is like this. It is a global digital identity protocol, somewhat like an internet passport. These credentials are like stamps in that passport. So orb verification is the strongest credential. Right now, we also offer phone verification, which is a much, much weaker credential where you verify that you control a phone number in the app. It's useful in some situations, but for a lot of other situations, you'd want the really strong proof that orb verification provides, which is why you can configure which one you want to use when you're using World ID, and I can explain more about that later. Right? Okay, I went over these credentials already. So World ID is built to be privacy first. It's decentralizing, right? And it's open source. So decentralization is a gradual thing for us. If we had started out fully decentralized immediately as a DAO, then we would end up a lot shorter than we've gotten today, right? Building things is tough, especially when there's hardware involved. But we want to decentralize as much as possible. That's why we have the Worldcoin Foundation that stewards the protocol, whereas Tools for Humanity is the corporation like building the orbs and things like that. And it's open source, so the smart contracts, our front-end widget, all of that is available on GitHub. There's a lot of different use cases for this proof of personhood system, right? Voting is one that makes a lot of sense. You want to let someone vote, know that they're only voting once, and also de-anonymize themselves between their different votes. Anonymize themselves amongst their different votes, right? So that you can't just look at someone's voting history. For customer incentives, this is one of my favorite use cases, where say someone's orb verified, you know really strongly that they're only going to be able to claim that like sign up discount once. Maybe you give them 50% off their first order. Whereas if they're phone verified, it's a much weaker credential. You still want to give them something, maybe 5% off their first order. And you do that because with the phone credential, there's a higher chance that they're going to be able to create another account, verify again, right? Like I know I have gotten months of free Netflix out of spinning up new emails to get that 2-week free trial. And we built World ID also to be super easy to integrate. You can use it on web, on mobile, and on chain. And there's 2 main ways to integrate World ID. You have sign in with Worldcoin and anonymous actions. So sign in with Worldcoin essentially wraps World ID in an OpenID Connect provider. So if you've ever implemented like sign in with Google in an app, it's extremely similar. Anonymous actions are a little bit more flexible. That's where you can ensure a user's doing something only once for the Sybil resistance. And anonymous actions you can do both, just on the web as well as on chain. So let's start with talking about sign in with Worldcoin. And let's see how it works. So I will actually demonstrate this for us right now by signing into our developer portal, right? And we can see my phone right here. So for me to sign in with Worldcoin, which we have to use for our developer portal, right? I click login, pops up this QR code for me to scan. I tap the button in the top left in the app, scan the QR code. Oh, come on, don't fail me now. Let's try this again. I'll refresh the page. It's Wallet Connect underneath. Oh, interesting. Let's try it this time and see if it works. Here we go. So I hit verify with World ID, and that zero-knowledge proof is generated on my device. And now I'm signed into our developer portal. Yay! And I'll walk us through that a little bit more later. So there's a bunch of different ways that you can integrate sign in with Worldcoin. We have an integration with Auth0 now. So in about 5 minutes, if your app already uses Auth0 for sign in, you can add sign in with Worldcoin. We have a nextauth.js template. So if you are building on Next, you can implement sign in with Worldcoin super easily that way. If you're using some other authentication provider, you can use the OIDC well-known file, or you can custom build your OpenID Connect flows, or, there's plenty of different ways you can do this. But I'll walk us through how we would integrate it with nextauth.js. This one configuration file is all you need to integrate sign in with Worldcoin using nextauth.js. You're just creating a single provider for Nextauth. You give it the well-known file from our OpenID configuration, which is part of the standard. You have to pass it the client ID and client secret that you get from our developer portal. And then we map the information returned from our OpenID Connect provider to that user in your app, right? So if I want to create a client ID and client secret, first let's start with creating an app. I click up here, add new app. Let's just call this Paris test. So let's just say I want to go straight to production. If I want to use sign in with Worldcoin, I have to make it a cloud action. Create new app. I click sign in. I can get my client ID here, which is also the same as the app ID. And then for client secret, I reset it there. I copy it. I put it in the configuration. Additionally, I have to put in a redirect URI. So if you use our template, that's explained in the README. It's just the specific route that our OpenID or our sign-in page knows to redirect your user to after they've completed the verification with World ID. So once you've done all that, sign in with Worldcoin is already just implemented. It's that simple. And now let's dive a little bit into anonymous actions. So anonymous actions, you're able to know that your user is a unique human doing something once with a specific signal, right? And that signal is a lot more useful for on-chain use cases generally. So one example there is that if you're offering an airdrop and you want to make sure that your user, your users are real humans, they each just get to claim that airdrop once. What you would use the signal for is the wallet address that they are claiming that airdrop to, right? That signal gets used as a little bit of information included in the proof generated on the user's device that you can ensure hasn't been tampered with, right? So it would really suck if someone were to man-in-the-middle attack your app, change that address, and then the user accidentally submits a transaction claiming their airdrop to someone else's address, but using the signal prevents that, because if that gets changed, the proof won't verify on-chain. Right? So let's see a quick demo of what using anonymous actions looks like. So I have my little World ID playground. This is based on our cloud template, which is freely available for all of you to build on top of as well. Let me make sure my phone's unlocked. So I click Verify with World ID, and this opens up IDKit, our front-end widget, which is used for any situation involving anonymous actions. So I'll go ahead and scan this. Like, the flow for your user is very, very similar. Oh, this is a staging action. My bad. How about I use the simulator then? So when you're testing things, right, we have a simulator for that, especially if you're testing Sybil resistance. If you only have your one World ID on your phone to test with, kind of sucks. Simulator helps fix that, where we have a bunch of identities. Here there's 5, and you can always just add more. They say unverified. That will change in a few seconds. All of these identities in the simulator are already phone and orb verified. So if I want to go ahead and verify here with the simulator, I can actually click the QR code to copy the information there, go over to the simulator. I click manual input. Since I'm on desktop, you can also use the simulator from your phone. I click submit, and then here I can select which credentials I actually want to use as part of that proof. So if I wanted to test being only phone verified, I'd uncheck biometrics, only orb verified, uncheck phone, both, leave them both checked. With our proof system, we actually just return the highest credential. So phone and biometrics both checked versus just biometrics checked won't actually change anything. But I'll go ahead and click verify with World ID. If I go back here, successfully verified. And it tells me about this nullifier hash. That nullifier hash is sort of the unique identifier for a user in the context of an action, right? So if the same user tries to take the same action twice, they'll generate the same nullifier hash, which is how we can implement Sybil resistance. So let's go back to the slides, right? Everything using anonymous actions starts with IDKit. It's one React component. You can also use it with vanilla JavaScript. And you have to give it information about the action you're performing. So the name of the action, your app ID for that app you've created in the developer portal, the credential types you want to accept. It's an array of phone or orb. This is also TypeScript. If you're using non-TypeScript JavaScript, then you would just have strings orb and or phone. There's 2 callback functions. On success is mandatory, handle verify is optional. Handle verify is, it shows the user a loading state while that's being called and waiting for a response. On success is what gets called after the IDKit modal is closed. There's plenty of other things that you can configure, and our docs go over all of those, but this is basically everything you'd need. You also have to pass it a child button that opens the component when the user clicks on it. And then once the user has finished this flow with IDKit, this is the response that you get. You get a Merkle root, so the root of the Merkle tree against which you should verify these proofs. You get the nullifier hash, the unique identifier for that user in the context of that specific action. You get a really long hexadecimal string that's the proof, and that one you don't really need to worry about too much. You just pass that either to our API or the smart contract on chain when you're verifying that proof. And you also get which credential type that user's been verified with, right? But you have this response, you still have to verify it because that proof is sent directly to your front end from the user's device, right? We use Wallet Connect to create that connection between your front end and the World app so that the user can pass that proof to you. We do that because we can't monitor that. Again, we don't want to be able to associate actions back to the same user. So when we have a direct connection between the user's proof generation on their device and the thing they're trying to verify with, it helps keep that anonymity and that privacy. And you can verify that proof either on-chain or with our API. So if you want to do it with our API, you should first pass information returned from IDKit to your backend, because if you try to verify that proof with our API directly from your front end, the user can still manipulate the response, right? Nothing in the front end is secure. The user can always modify that. So you should pass it to your backend and then call our API. So developer.worldcoin.org/API/v1/verify/your-app-ID. You pass it information about the app ID, the action, the signal if you're using it because the signal's optional, and then the Merkle root, the proof, the nullifier hash, everything like that. Again, our template repositories already handle all of that for you to make sure that you can't do it wrong. And it's all of the required parameters for this API call are gone over in our documentation. So then if you get a 200 response from our API, great, you should go ahead and mark the user as verified in your database or whatever else it is you want to do after you know they're a verified human, and then send a response to your front end to let them know everything is good. For on-chain verification, it's a little bit more complex. So in the constructor, you'd set the address of the World ID smart contract that you want to verify against. If you're looking at our docs, you'll see contracts called the World ID router. Those are the contracts you should verify against. They are available on Ethereum, Optimism, and Polygon, both mainnets and testnets. So for testnets, it's Ethereum Girly, Optimism Girly, Polygon Mumbai. That is a new change that some of you who've hacked with World ID in the past might be kind of surprised about. We just finished our migration to Optimism yesterday. So we're super happy that now you can use World ID on a much broader variety of chains than just Polygon. And you can find the addresses for those contracts, again, in our docs. We have an address book that goes over everything there. The app ID and action ID are generally things that you would set in the constructor as well so that those can't be tampered with, and it also keeps things more gas efficient. The external nullifier is basically just the identifier that that Semaphore, the zero-knowledge proof system that we're built on, uses to identify that action the user's taking. It's a combination of your app ID and action ID. And then your verify and execute function will take in a few different parameters, like the signal, the root of the Merkle tree, nullifier hash, and then that proof. First, it checks to make sure we haven't seen that nullifier hash before, because you have to implement the Sybil resistance yourself in a smart contract. We call the verify proof function on the World ID smart contract. The group ID is 0 for phone credentials, 1 for orb credentials. You can also set that in your constructor if you only want to accept one or the other. You pass it the other information you receive from IDKit, and then if that doesn't revert, everything checks out. You add this nullifier hash to the list of nullifier hashes we've seen before so that you make sure that user can't do that same action again. Once that's all done, then you would mint them an NFT, let them claim an airdrop, whatever that may be. And in this hackathon, we've got 20 grand of prizes. I don't need to read all of these to you. You can look at them on the website or just read them right now. If you have any questions about them, feel free to find me at our booth. And then we have a bunch of resources for hackers as well. So worldcoin.org/Paris23 will take you to a Notion page that goes over our bounties, links to our template repositories, our documentation, everything you need in order to build on World ID. I'll give everyone a little bit to scan that QR code. I mean, it's just my closing slide after this. I might as well just leave that up for everyone. Any questions? I think, yeah, you there?
Yeah, thank you so much for the talk. In the very beginning when we entered, you mentioned that when you generate the ID, based on the orb with iris of the human eye, you check that it is unique.
Yeah.
Right? Two things. Have you mentioned the cases when it's not unique, and what you do if you get the same thing here?
Yeah, so the way that we check that it's unique is that iris code and the public key of your identity get uploaded to Worldcoin servers, and then our servers compare that iris code with all of the other iris codes that we've seen before. We don't actually check strict mathematical uniqueness. We use the Hamming distance. So how different are these two iris codes when comparing 1 to n, because your iris code can change slightly over time, right? Your iris will just change a little bit as you get older, and then it's like, is it different enough from all the other iris codes? In the situation where we do have a user whose iris code is too similar to one that's already in the set, we simply just return like, hey, you've already signed up, right? The orb will tell them that the verification is not successful. And then we don't insert the public key of that identity into the Merkle tree. We just turn them down, right? Because for us, like our algorithms on the orb right now, we are extremely confident they can handle 1 in a billion today. So the odds of a true collision in that iris code is so unbelievably low.
What about Russ? Yeah. What about the identical twins?
I'm sorry?
What about identical twins? The twins?
Oh, twins have very different irises.
Okay.
Even identical.
I didn't know that. Okay, thank you so much. That's it.
Hi. Could I somehow take a full list of verified users
No.
on chain? I mean, no.
Like you can have the Merkle tree of the, public keys of the identities, right? And one thing to note is that the key pair for your identity is completely separate from the key pair for your wallet. So like that Merkle tree is publicly available, but the public key of that identity is only ever revealed when you're getting like verified at the org. Because anytime that you are using World ID to verify to some other app, you're just generating a zero knowledge proof that you're one of them in that tree. You don't tell them the public key of your identity. So we do that, again, in order to preserve users' privacy. So no, you can't see just a list of all of the identities that have been verified.
Could I be able to get such list after the airdrop? Would I be able to take such list of all of the verified users after the airdrop? I mean, the Worldcoin, the exact coin.
Well, with Worldcoin, we do token grants over time. So the token is still not yet live, but users can claim beta grants of the token, 1 per week. So yeah, there's not like one moment.
Hi, I have a great idea for the hackathon, which is decentralized science, getting responses from the real users, some behavioral economics. If you're looking for the team, please join me. Decentralized science and tapping into unique users, running some social experiments, behavioral economics. Please join me. Thank you.
Okay, this guy's had his hand up the whole time.
Hello, thanks for the presentation. So I have a few questions. I mean, how much time you have, I don't know, but let's go with the first one. So what does with the data? What happens with the data in, the orb scans my eye, and then what happens with that data?
So if you didn't opt in to having the photos stored, they get deleted from the orb. If you did opt in, they are uploaded to our servers in Germany using sealed box encryption. You can choose to have them deleted at any point in the future. And then there are 2 things that we would use those photos for. One is that if we significantly upgrade our iris code algorithm in the future, we would be able to just run that algorithm on the photos that are stored for users who opted in, whereas users who didn't opt in would have to go back to an orb to re-verify. We can also use those images to help improve our algorithms and make them more secure.
Okay. And what gets stored on chain?
What gets stored on chain?
Yeah.
The only thing that's stored on chain is that Merkle tree of the verified identities.
And what's inside the Merkle tree?
Just the public, it's the identity commitment, right? Essentially the public key of these identities that never gets revealed in any other situation.
But it's like a hash?
It's the public identifier of that identity.
Okay.
It's just like you have the wallet address of your wallet. This is the public key of your identity.
Thank you very much.
Thank you.